is that I know it's only week 14, but I say it's already week number 14. So that's this week. So here's the deal. Week number 15 is next week. And I know that we have really 2 more weeks after this, but really it's a 7-day week. So it goes all of next week plus the 2 days before our break. So those 2 little days that Christmas falls on, we won't have any new material. That'll just be work catch-up days. We won't have any other live classes because we won't have new material. So then after that, we have a nice almost 2-week break. Woo! And then when we come back, we have week number 16, which will be our final set of new material. And then week 17 is just going to be semester review. We won't have any live classes. That'll be get the things in that you need to get fixed and in and so on. And then with things that the way that they are, I am going to make exams optional during week 18. So really this is our third last week of new material before second semester. We have 14, 15, and then 16. So it is going to fly. I know it seems like, oh, we're just on week 14, but man, we're already there. So with that being said, let's get into what you saw for week 14, which talked about isosceles and equilateral, equiangular and equilateral triangles. So hopefully we got a chance to watch that, but if not, then we will just, again, yeah, motion optional. When I say optional too, when you said optional question mark, that just means that if you take it, you can try to take the exams to raise your target scores, but I will definitely not count them against you if they lower them, or if you just don't want to do them and you're too stressed and need to get other things done, then skip them. That's what I mean by optional. And we'll talk more about that. That's my little present for you, my New Year's present. All right, so taking a look at, and again, one more time, that Desmos link is in the chat. As we take a look at this, let's just quick do a nice warm-up of our definitions for the isosceles triangle. So isosceles is when we have 2 of the 3 sides being congruent. So it says right off the bat on the screen, let me see if I can zoom this in a bit. Oh, there we go, that's nice. So our base is this down here. And you don't have to do this on Desmos. We'll just go through this one together, and then we'll try the problems like 1, 2, and 3 on Desmos, so y'all can try them on your own. Now, that means the other 2, the 2 sides that are congruent, are called our legs. So the only reason I'm going through this, the definition kind of piece, is because if a question asks you to explain, you can use these terms, correct? So that's an X, Z, and an XY. So then our base angles, as it talked about in the recording, if you have a side, it's going to relate to its opposite angle. When I say opposite, when we are talking about opposite, just remember it's the angle that does not touch that leg. So as I trace that angle, Y, notice it does not touch the opposite leg, which is how I know it's the opposite. Same with this one. If I traced these 2, I know what the opposite side is, because it's the only side that is not supported or touching or part of the angle I just drew in, if that makes sense. So the 2 congruent sides are opposite the 2 congruent angles, which we call our base angles. So getting rid of some of those drawings in there. There we go. Our base angles are also congruent because they are opposite our congruent legs. All right, so the base angles are Y and Z. Angle Y, angle Z, just as a refresher. And that means our vertex angle, the only one that's not equal, is up top. It is placed in between those two congruent sides. So before we get into problems like 1, 2, and 3, any questions on just what those parts of that triangle are? All right, let's do it then. So we're moving on. So if we move on to screen number 2, it gives examples. Actually, the next 2 I'm going to open up. The next 2 give you examples like questions 1 and 2 if you look on my screen here. So for all of these, looking at where the congruent angles or the congruent sides are, can we find missing side and angle lengths? So most of these are going to focus on isosceles triangles, which have the 2 congruent legs opposite the 2 congruent base angles. Whoops, let me go up here. Whoopsies, let me go up here a little bit. There we go. All right. So what I'm going to do is I want you to head into this slide number 2, and try these problems. The first one's done for us. We know that, and we are given that we have 2 legs that are congruent. So that means the opposite base angles are congruent. It's a 90-degree angle, so these 2 have to be split equally between 90, so it's 45. Perfect. So again, same thing here. Can you figure out what side length AC is, what the measure of angle K is, what side length J, this is an L down here, is, what angle Z is, and what QR, side QR is. So again, I'm just going to shut it for a minute, let y'all go into the Desmos and give this a try. So I see Eric, Evan, and Imogen, and Athena, you're having a little bit of a problem. I know you said, so that's, I gotcha. Is Evelyn or Jack or Noah gonna pop in? Again, if you missed the Desmos link, here it is. Boop. So let's just take literally a minute to 2 minutes and try these. As y'all are working, I'm just going to leave some feedback in the little chat for each of you working. All right. So just another 20 seconds, and then we will go through these together. Those of you that are in Desmos, I see you got most of them done. All right, here we go, folks. Let's give these a try then together. And if you want to pop things into the chat, if you want to answer them, if you didn't answer them in Desmos, or you have questions as we go, please, by all means, let's do that. That's what we're here for. So this second one, I'm going to kind of walk through it, but it's giving us, so look at what they give us. They give us that these 2 base angles are congruent. That means I know that their 2 opposite sides are also congruent. So right off the bat, I can mark those. So it's asking, what is AC? Well, those of you that did it on Desmos did this perfectly. We know that these 2 are the same, so AC is also 1. Lovely. The next one's a little more challenging. It gives us that these 2 sides are congruent. So by definition of isosceles triangle, we know that the base angles are also congruent, but we don't know what G is and we don't know what K is, but can we find H? That's kind of where the tricky piece comes in. Notice these are two lines that intersect each other. So these angles indeed are vertical angles. Hopefully you saw that. And from last week, one of the things we used from last week is we know the sum of all of the angles in a triangle is 180. So if that's 28, and these two have to be congruent, we have 180 is the same as 28 plus the angle plus that same angle, right? Two of the same thing. Or maybe mathematically in your head, you're just saying, okay, well, I have to take away the 28. And then cut that in half. Is that what we did? So then when we cut that in half, we get 76. So a 76, and a 28 together give us 180. Just kind of pausing to see if there's any questions, but it looks like we're okay right now. Okay, so going on to the next one, it gives us that these two sides are the same, but I also see that it gives us that all three angles are the same. So if all three angles are the same, all of their opposite sides are also the same. So even if they didn't note that, I know that the opposite side of this angle, the opposite side of this angle, and the opposite side of this angle are all equal. So that means JL is also the same length as the rest of them. So 12 roux. Going on to the next one, looking at what I know that this side is 7 and this side is 7, which means these two are congruent. Which by definition of isosceles triangle opposites, we got 45. And then the last one, again, these base angles are congruent. So I know their opposite sides are congruent. So these two are congruent. So QR is not 15. 15 is my base. It's congruent to the other leg of 10. Any questions on that one? What about the next one? Just be careful because on something like question number 2, and even on question number 1, make sure you look at where the tick marks are. So this doesn't even look, it kind of looks a little skewed, but look at the tick marks are here. So we know they're opposite base angles are congruent. So this is our base, this is a leg, and this is a leg, okay? So it says what it gives us is KL and JL are congruent, given. Angle J is, I always draw these out on my own piece of paper. J is 4x. And then it says angle L is 2 times x minus 5. Right? Angle L is this. Angle J is this. And it says find the measure of angle K. How would we do this? So I also know that angle K is also 4x, correct? No disagreements there. I'm just going to quick take a peek in Decimos. Hope I see a couple of you started that one. Good. Do you guys just want a second just to try this one on your own? So again, I'm going to delete this. So here's what we know. Since we know that these two are the same, we based on the definition of isosceles triangle, and you might use that as an explanation in one of your assessments, wink, wink, this week. Your only assessment this week is that by definition of an isosceles triangle, the base angles opposite the congruent legs are also congruent. So our base angles would be this angle is opposite this side. This angle is opposite this side. So even though it's flipped on its side, these are the two that are congruent. So because it tells us that angle J is 4x, because these are congruent by definition of isosceles triangle, K is also 4x. That makes more sense? So, okay, I know this is 4x, I know this is 4x, and I know this is 2x minus 5. What do I know about the sum of all the angles in a triangle? If I had to, I could do this, correct? Whoops, not plus, but minus 5. I know it's twisted on its side. Yep. So we always go by the markers, not by what it appears to be. So if we wanted to set up an equation, that's what it would look like. Question 2 isn't even asking you to do that, though. I wanted to show you how to in case you needed to do that in something like the advanced. But question 2 is really going to focus on this piece right here. How do we know that that's isosceles? How do we know that this is an isosceles triangle? Because you're right, Imogen, it doesn't really look like it. But we know it is because anybody want to take a stab at that? And again, this is the reason that we have little tick markers is sometimes things aren't necessarily always drawn to scale, so they don't look congruent, but that's why we use our angle measures. But how do we know that this is isosceles? Anyone want to take a stab at that one? Again, question 1 on the assessment going back is going to be more of here's the picture, here's the congruences, name the angle or the side length. Question 2 is going to give you a drawn out picture and going to ask something like, how do we know that this is isosceles? How do we know that this is isosceles? So using isosceles, we can, of course, always set up equations, but question 2 is simply going to ask, how do we know? And we don't even, Eric, you're perfectly right. That's awesome. And Imogen. So Eric, you're definitely right. It says if two sides are congruent, then opposite angles are. But we don't even care about the angles being congruent, do we? It says, how do we know this is isosceles? Well, we know because by definition of isosceles, we have two sides congruent. Right? And given to us as the JL and the KL. We know because it's told to us. Now, if we were given the angles, we could say, if I know two base angles are congruent, I know their opposite sides are, and the definition of isosceles just says that I have to have two sides that are congruent. Done. So if you're given the sides, automatically we know it's isosceles. That's the definition. If you're given the angles, we got to revert back and tell how we know the sides are congruent, like what you're doing, Eric. Perfect. And then we can move forward. Okay, let's move on to the last type of thing you're going to see. What you're going to see, like questions 3 and 4. Can you actually find it? So we kind of looked at on the question 2 one how to set up the equation. So how do we do it for this one? Triangle ABC is shown. Can we find angle C knowing that angle A is 56 degrees? If so, do so and measure. We can, right? We can find that. We did that on a couple earlier ones. Let's just take 30 seconds to try and get that one started in Desmos. I know a handful of us are working in Desmos. Awesome, Eric. Great start, great setup. Also a great setup, Emojin. Yep. All right, we're rolling. And I know the rest of us are working on our own papers, and that's totally fine too. All right, let's do this. Looks like most of us in. Yeah, that's so awesome. Good job, Eric. I'm just looking in Desmos for those of us that got it. Awesome. Okay. Yay. Okay. So the setup would be, we know the three angles in a triangle add up to 180. So whether you put 180 on the left or 180 on the right, that doesn't matter. But it's going to be the sum of this 56. And these two are the same. So although I don't know what they are, I'm going to name them as X. So one X and another X. So some of us right off the bat know that that's two X's. So I have 56, that top vertex angle, plus two unknown X angles. Okay, before we solve, are we good with that setup? That's the big setup there. Again, those tick markers, so important to know, they mean that they're the same measure. It looks like we're feeling good. So then to solve it, we move our constant first. So again, if those of you are doing it this way, just to show how I'm getting the 124. The 56 is cancel. I'm just left with two X's. So 2 times X, I'm going to divide that in half. Some of you are doing that by hand. Some of you know, which is fine either way. But our X value is 62 degrees. So it says, if so, find the measure, show your work. Just show your setup and your answer. So with that being said, what questions do we have? And then I'm going to take the last 5 minutes to answer any questions you have. And if you don't have questions, if we want to just, again, quickly review the things in 11 and 12, I know that's a little trip up for some of us. We can do that too. Those were the tricky sections. If you have any questions, throw them in the chat or on your Desmos page 4. I'm looking on there too. Are you able to flip it around and do it that way? What do you mean flip it around? Oh, yeah, absolutely. Yeah, great question, Athena. So yeah, so and probably most of you do it this way. 56 plus the 2x is going to give us the 180, right? Yeah, most of you probably set it up that way. Great question. Thanks for. So then, yeah, you still just minus or subtract your 56. So your two x's equal your 124, and then cut that in half. Boom, ba-da-doom, boom, boom. Wonderful. Okay, so since we have no other questions, again, just week 11 and 12, I wanted to go over a quick review of exactly what the questions kind of are asking for and how to decipher what kind of answer you need. Unless there's other questions that we have. Okay, so as a refresher, if the problem's saying prove or tell me why one triangle is equal to another, our answer options are going to be things like side, 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 angle, angle, side, angle, 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 side, and hypotenuse leg. So if you're ever just proving two triangles are congruent, your answer options will always be one of these. Okay. But if it's saying, tell me why angle A is equal to angle B, or if it's saying, tell me why AB is equal to CD. So if it's asking for sides or angles, the first thing you got to ask yourself is, do I know the triangles are congruent already? So like, for example, if I gave you these two triangles, boom, boom, and this was A, B, C, and this was D, E, F. And I gave you this. I said, these two are the same, these two are the same, and these two are the same. And I asked you to tell me how you know that DE is equal to AB. So you're doing this. So you're not using one of these, but you would say, oh, well, I know that triangles are already congruent, right? The triangles are congruent by side, angle, side. So by congruent parts, corresponding parts of congruent triangles are also congruent. That's how I know that DE equals AB. Once you know that the triangles are congruent, all their other parts are congruent. All their other parts are congruent. But on the flip side, if I gave you this problem, and I said, tell how you know angle ACB is equal to angle DCE. One, it's not, again, going back, it's not asking for the triangles, so I'm not using these. Do I know that these triangles are congruent already so that I can just say the angles are congruent by CPCTC? No, I'm not given a single thing, right? So now I have to look at the only other options I could possibly have, which are vertical angles, alternate exterior angles, or reflexive, which means they're the same side. So in this case, if I drew these out, A, C, B is this angle, and D, C, E is this angle. Oh yeah, I know that they would be congruent by vertical angles. So if we're not given congruent triangles, I'm going to have to use one of these as an explanation, like in a proof. If I don't know triangles are congruent and I don't have any pieces yet, I'm going to use these to explain why a piece is congruent. But in a proof, if I already know the triangles are congruent and then I need another piece, I'm going to use CP/CTC. So like what that might look like in a proof, just as a quick review here. So if I have a proof, I'm given this. So up here in the proof, if I say, oh, why is angle ACB equal to angle DCE? And maybe I'm going to say AC is equal to CE given. Maybe I'm given these. And I'm also given BC is equal to CD. So that piece is given, but then I need to fill in why are these angles congruent, and then I need to try to figure out why ABC is equal to EDC. And then I need to tell why or how I know AB is equal to DE. So again, up here, if I'm looking for a piece before I know triangles are congruent, my options are either going to be vertical, alternate exterior, or the reflexive property. They're the same side. So right away, I know these are then congruent by vertical angles. If I'm looking for triangles, I know it's going to be side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, legs. So now I have side, angle, side. Then if I'm asking for a side or angle after I know the triangles are congruent, that's when I use CP/CTC. So hopefully that, again, as we keep working on that, that's what you were doing in weeks 11 and 12. So just another